Okay, let's look at the limits of piecewise defined functions. Right? So let's dive right into a couple of examples. Right? So first one. So f of x is a piecewise defined function, and x plus 2 if x is less than -1, and the square root of x plus 2 if x is greater than -1. Right? So let's evaluate the right-hand limit of f of x as x approaches -1 from the right. Right? So this is going to be, right, so it's right-hand limit, so limit as x approaches -1 from the right. Right? So since we're approaching from the right, so it's going to be, x has to be greater than -1. So we have to actually use the bottom formula, right? So you have a square root of x plus 2, right? Then if you have a square root, you can actually put the square root, put the limit inside the square root. So this is going to be square root of limit as x approaches -1 from the right of x plus 2, right? So since this is just a linear function and it's a kind of a polynomial function, so we can plug in. So if you plug in, -1 plus 2 is square root of 1, which is 1. So I'm going to go ahead and write 1. Right? So we have that. And the left-hand limit, so since we're approaching from the left, we have to use the top formula. So this is going to be limit of x plus 2 as x approaches -1, right? So this is going to be equal to, right, again, plug in -1, -1 plus 2 is 1. All right. Then the two-sided limit, since the right-hand limit gives you 1 and also the left-hand limit gives you the same value 1, so therefore two-sided limit is going to be, of course, 1. Right? All right, maybe I'll say since A and B are equal to 1. All right, and part D. What is f of -1? And we try to plug in -1. But unfortunately, this function is defined when x is strictly less than -1 and also strictly greater than -1. So this function is undefined, or you can say it does not exist. Probably I'll write D and E for does not exist. Right? Because function is not defined when x equals -1. All right, so let's look at the second example. All right, so if you have f of x is equal to x minus 3 over absolute value of x minus 3. All right, remember that the absolute value function is a hidden piecewise defined function. Right, so let's write it as a piecewise defined function. So this is going to be equal to, all right, so this is going to split into two cases. If x is, right, when x is greater than 3, so x is greater than 3, and also if x is less than, strictly less than 3, right? So if x is greater than 3, absolute value sign does not do anything because x minus 3 is going to be always positive, which means that this function is simply x minus 3 over x minus 3 without the absolute value sign, right? But we can cancel those guys out, so x minus 3 over x minus 3 is 1 because you can cancel top and bottom. All right. if x is less than 3, then absolute value sign will negate it so that the x minus 3 becomes positive. So you're going to have x minus 3 on top, and absolute value sign will negate x minus 3. Right? So only difference is we can still cancel, x minus 3, x minus 3, but there's a negative sign, so this is going to give you actually -1. Right? So this guy is actually a piecewise constant function. X is greater than 3, it's +1. If x is less than 3, it's going to be -1. Right? So let's look at the part A. So this is a right-hand limit. So we're looking at, let's see, x is greater than 3. It's the top formula. So this is going to be equal to limit of 1, +1, as x approaches 3 from the right. But this is going to be equal to 1. Right? Limit of a constant function is the same constant. All right, part B. This is a left-hand limit, so if you're doing a left-hand limit, we have to look at the one when x is less than 3. And the formula is, let's say limit is a -1, which is the bottom formula, as x approaches 3 from the left. But the limit of -1 is still -1. All right, part C. Part C, we don't really have to do a lot of work because we know that the left-hand limit, a right-hand limit is 1, left-hand limit is -1. Since they do not agree with each other, so we know that the two-sided limit does not exist. All right, so justification is since part A does not agree with part B. All right, and part D, f of 3. Right, so when x equals 3, exactly equal to 3, denominator becomes 0, which means that the function is not defined. So f of 3 is undefined, or we can just say does not exist. All right, so these are the two examples of limits of piecewise defined function. All we have to do is when you do a one-sided limit, pick the right formula, then go ahead and evaluate. And two-sided limits, you can kind of look at the left-hand limit and the right-hand limit. If they do agree with each other, that's the same number. If they don't, then the two-sided limit does not exist. All right, that's it. I hope that this was clear.